Hey VC students, welcome to another video of hok'stutoring. I hope you're having a great day. Well, today we are going through a tutorial video on chapter 3E. So that is determining sequence of transformations. So on the screen you'll see question 1A as an example. And I'm just going to show you the tips and tricks on how to find sequences of transformations when you're given an old graph that has been then transformed into a new graph. So without further ado, let's get into the question. So question 1A. For each of the following, find a sequence of transformations that takes the graph of y equals to x cubed to the graph of y equals to, and then you've got three separate graphs. So before we get into the video, I'm going to do a quick revision again on the different transformations that you do in methods. Those three transformations are translation, dilation, and reflection. So we're going to be using the mapping technique, meaning you have an old x and an old y coordinate or values that is then transformed. In this case, for translation, you add values or subtract values to the x and y, and then for dilation, you multiply values to the x and y. Now, if you are dilated from the x-axis, you change the y value. If you are dilated from the y-axis, you change the x value. And as we discussed in the previous video, the reason for that is if I have a point or a graph on a point on a graph, in this case, if I'm dilating from the x-axis, being the horizontal axis, then I'm moving away from it or closer to it. Okay, so it's going up and down, which in fact, even though it's from the x-axis, you might think, oh, that's changing the x value. It's actually changing the y value because it's moving up and down. It's going from the x-axis. And vice versa, when it's dilating from the y-axis, it's actually changing your x value. It's going horizontal from the y-axis up over here, okay? And then the last part is reflection. So meaning you are essentially just putting a mirror on one of the axes and just flipping your point. So if you're reflecting upon the x-axis, you are changing the y value, similar to dilation. And if you're changing, or if you are reflecting upon the y-axis, you're changing the x value, just putting a -1 in front of the x, okay? So that is the revision of the transformations, and this is the mapping technique, guys. We're going to apply that over here, so let's get into the questions. So for the first one, and when I do these type of questions, I always like to have an old and a new, okay? So I want to have an old graph and my new graph. So my old graph in this case is y equals to x cubed, and my new graph, at least for part I, is y equals 2x minus 1 cubed plus 3. Now, if you've done a lot of transformation questions, you could already probably tell some of the transformations that's been applied from the old graph into the new graph. So for example, like that plus 3 right there is immediately a vertical translation upwards, or at least translation in the positive direction on the y-axis. But that is, that's just telling it from base of your experience. But let's say you want to use a method, you want to show some working out. How would you apply that? Because guys, you need to be able to apply it, not just for your simple one like translation. You have to also apply for dilation, and sometimes your graph gets really weird and you need some kind of a more structured way to find the sequence of transformations when you're given these types of questions. So we're going to go through the mapping technique like we did last time, but this time just a little bit in reverse. So when you have your new graph, what I want you guys to do first is put a prime in front of, or a dash in front of the y and the x, to just signify that these x and y's are your new graphs, and then these y and x's without the apostrophe are your old graphs, your old coordinates, which has then been transformed into your new coordinates with the dashes, okay? So the next step, if you want to find the transformations, you want to make them look similar, because you want to be able to see like a pattern of what happened to, your y over here and what happened to your x over here. So you kind of make the new graph, make it look similar or in a similar format to the old graphs. And how you do that is, it's always the same process every time, guys. When you do these questions, is you move anything outside the bracket, right? Anything outside, not close to the x or part of the x values, over to the y values. So in this case, the plus 3, you move it over to here, and then the 2 in front of the bracket, that's not part of the bracket, not part of the x, right? So then you divide it by 2 over here on the left hand side, and what you have left on the right hand side is just anything related to your x values, okay? So what I'm trying to do here is make it so that it's in a similar format to your old graph. So if I just put a bracket over here, you can kind of see the similarity here. So the y is now the y here, and the x in the bracket cube is now x here in the bracket cube as well. Just a little bit of a transformation that happened to it along the way. So in this case, now that you have the new form that looks a bit similar to the old form, you can start equating things together and try to look at the transformation. Because the idea of the mapping technique is you want to find the new x in terms of the old x, and you want to find the new y in terms of the old y. Because if you know what the new x is in terms of the old x, then you can apply these transformations. Okay, so we're going to go further into the example. What I can tell straight away is that my y value over here, the old y, is equivalent, or technically is equals to this on the new graph, and my x value over here, the old x, is equivalent to the new graph, or the new x minus 1, right? So that's the same thing. And what I'm trying to do is I'm trying to make the new x and new y in terms of the old x and the old y. So what happens here is, if I'm just shifting, making y prime or y dash the subject, I just moved everything over to the other side, and I multiply y by 2, and I add a 3 on top of it. And then same thing with the x prime is equals to the old x plus 1. And that's the tip I have for you guys. You need to make the graph in a similar format to your old graph, so then you can try to equate old x and new x, old y and new y together, and then you can then use a bit of algebra, manipulate it, so then you have the new y in terms of the old y and the new x in terms of the old x, in which case once you get up to this part, guys, you can then apply your transformation. So let's have a look. What happened to your y values to get to your new coordinates, the y dash, right? So first of all, there's a number 2 in front of the y, and we go look over here, back at our cheat sheet. If there's a 2 in front of the y value, which is the first part right here, that is a dilation from the x-axis. So immediately, the first transformation is dilation by a factor, and I might shortcut some stuff here, by a factor of 2 from the x-axis. Okay, and I'm just gonna squeeze that in just at the end. So you have a dilation by factor 2 from the x-axis, and then you also have on the y part at least a translation. And as we said before, see, it moved up by 3, and over here it's also evident that there is translation of 3 units in the positive y direction. Okay, so again, translation, if you have a y value that is added to a number, or a number added to the y value, then it's a translation in the positive direction of the y-axis. And then you go look at the x, and again, it is x plus 1. So you have a translation. What you're doing to your old x to get your new x is you add 1. So there is a translation of 1 units in the positive x direction. Okay, I hope that makes sense, guys. So just be wary that when you're doing transformation questions, and especially these types of questions where you're listing out the sequence, you need to use the Dr. T format. So meaning dilation first, reflection first, and translation afterwards or last, as the order actually matters. Okay, so guys, that is that for part I. I'm just gonna go through one more. Let's go through double I as another example, just to finish off the example for this video. So we have the old graph being y equals to x cubed, and we are transforming it into y equals negative x plus 1 cubed plus 2. And again, applying the tip. Okay, so step number 1 is you want to put a dash on your new graph. Whatever your new graph is, put a dash on top of that, so then you know, okay, these are my new x and my new y coordinates. Okay, so afterwards what you do is try to make the new graph look or have a similar format to the old one. So similar to what we did up top, we move the 2 over to the other side, and then we can divide both sides by negative 1. And then on your right hand side, you just have the x only. And then same thing over here. This is just x cubed with a bracket. Okay, So once you have it in this format, guys, you can then try to compare them together. So my old y is equivalent to my new y minus 2 divided by minus 1. And my old x is my new x plus 1, right? You don't have to worry about the cube. That's already there. That's the same. So the only thing you need to look at is, what happened to your old x and what happened to your old y, right? So in this case, if we try to just transform it, or at least try to make y dash and x dash the subject so that we can then find out the transformation, then all we need to do is just rearrange, and we get negative y plus 2, and then on this side we have new x being x minus 1. And listing out the transformation, well, we look at these over here. What happened to your old y? Well, there is a reflection. And again, if you are changing your y value, then you are reflecting upon the x-axis, okay? So back to our cheat sheet, if you are changing your y value over here, then you're reflecting upon the x, okay? So dilation and reflection works in the same way. Reflection upon the x-axis. And then over here, we have a translation. So translation of 2 units in the positive y direction, okay? So it just went 2 units up, and then over here on the x we have a translation again, translation of 1 unit, and because there's a minus 1, you put in the negative x direction. Okay guys, so that is how you apply transformation. The important tip is step number 1, make sure you put a dash in front of your or at least after your old x, after your new y and your new x, and then afterwards make it so that your new graph has a similar format to your old graph, because then you can equate them together to then rearrange to solve for what the new y and the new x is in terms of the old y and the old x. Afterwards, you can just then apply the transformation, the mapping techniques for transformation, and you'll be able to determine the sequence of transformations. So guys, that is it for today's video. Question 1 of chapter 3E, I believe. If you have any questions, please let me know in the comment section below. Otherwise, I hope you found this video useful. If you did, please leave a like and subscribe to Hok's Tutoring YouTube channel. I'd really appreciate it. Thanks for watching, and I'll see you in the next video.